182 talks about voltaic cells, and voltaic cell is just another word for a battery. And what is a battery? Well, a battery just uses a chemical reaction to create electrical energy. Basically, you're using the energy of a chemical reaction to convert into electrical energy. In this case, that electrical energy involves the flow of charged particles, in this case, flow of electrons. So what you're using is the natural chemistry of matter to create electrical energy using the flow of electrons. This flow of electrons causes the creation of sides that are polarized. Basically, as electrons go from one side to another in this voltaic cell, one side starts to become more negative and the other side starts to become more positive. To help maintain the balance, we use what's called a salt bridge. A salt bridge allows the migration of ions from one side to the other to maintain a balance in charges as the voltaic cell proceeds. We would say that a voltaic cell uses a spontaneous chemical reaction to power an to create electrical energy. So this happens naturally. And how do we know something occurs naturally? Well, if you recall, table J lists common oxidizers. The higher the metal is on table J, the more powerful, the more likely it's going to oxidize, meaning the more likely it will transfer electrons. So if we use two different metals, notice that one of those metals is going to want to more easily oxidize compared to the other metal, and that flow of electrons is what creates electrical energy. So let's use this to solve some problems. Which energy conversion occurs in an operating voltaic cell? Notice that all the answer choices involve some conversion of one type of energy to a different type of energy. And if you remember from the definition, a voltaic cell is only using chemical energy to convert to electrical energy. So answer choice 1 is correct. Which ionic equation represents a spontaneous reaction that occurs in a voltaic cell? So remember, in order for it to be spontaneous, the two metals in question that are reacting have to be present on table J, first of all, and one of those metals has to be more active than the opposing ion. So notice that zinc is higher on the activity table compared to copper. As a result, zinc will be able to transfer its electrons to copper in a voltaic cell, therefore making it a spontaneous redox reaction. A redox reaction will have both oxidation present, which is where the ox comes from, and a reduction present, meaning that one of those atoms is going to lose electrons, in this case zinc, and copper is going to gain electrons, causing it to be reduced. Therefore, copper will be reduced to copper solid, and zinc will become oxidized to become zinc 2+. Base your answer to the question on the diagram of voltaic cell and the balanced ionic equation. Explain the function of the salt bridge in the voltaic cell. Quite frequently, it'll give you an equation that shows the overall reaction occurring in the voltaic cell. So notice here, Mg plus nickel ion produces magnesium ion and solid nickel. So what's happening here? Well, magnesium is becoming oxidized and nickel is becoming reduced. So that means that the flow of electrons is going from this solid magnesium to this wire into these nickel ions. These nickel ions become reduced and form solid nickel. So what will happen to the amount of positivity on this side of the container? Well, if these nickel ions are becoming neutralized, then the level of positivity is becoming lower. What's happening to this side of the container? Well, as magnesium is getting oxidized, it's creating positively charged magnesium ions. So this side is becoming more positive. If this side is becoming more positive and this side is becoming less positive, that's going to create a polarity between the two. So what's the function of the salt bridge? It allows ions present in this solution to flow where they need to flow. In this case, the positive ions will flow to the right side and negative ions will flow to the left side in order to maintain a balance between these two containers. So you could simply say that the salt bridge helps maintain electrical neutrality. You could also state that the salt bridge is necessary for the transfer or migration of ions. Or you could say that the salt bridge prevents polarization of the battery or the voltaic cell. A student constructs an electrochemical cell during a laboratory investigation. When the switch is closed, electrons flow through the external circuit. The diagram and equation below represents the cell and the reaction that occurs. State in terms of energy why this is a voltaic cell. Notice that on table J, aluminum is much higher than nickel on the activity series. As a result, aluminum is going to become more easily oxidized and transfer its electrons to this nickel inside the solution. And it's also expressed inside this chemical reaction. Notice that the aluminum becomes oxidized to aluminum positive 3, and the nickel takes those electrons and becomes nickel ion and becomes nickel solid. So what makes this a voltaic cell? Well, a voltaic cell uses chemical energy to convert to electrical energy, and we would say that this is a spontaneous reaction. So you could simply state that the reason why this is a voltaic cell is because you're using a spontaneous reaction to convert chemical to electrical energy. You could also simply state that unlike an electrolytic cell, this does not require a battery to provide energy for the cell to operate. The energy is powered by the natural chemical reaction that happens when aluminum transfers its electrons to these nickel ions. So when it comes to voltaic cells, remember that it uses chemical energy to power or create electrical energy. Every voltaic cell requires the need for a salt bridge, and the salt bridge helps maintain an electrical balance within the voltaic cell by allowing for the migration of ions within the salt bridge. So basically, the sides don't become polarized and prevent the reaction from occurring. Thank you for watching, and hopefully this was